Welcome to Signals and System subject classes. Now we are in the fifth chapter, that is continuous time Fourier transform. So this is the seventh video. In previous videos, we have discussed some basic problems. So in this video, I'm going to explain some previous year questions asked in the Indian Engineering Service Examination, which is conducted by the Union Public Service Commission. So these are the previous year questions. These are asked in electronic communication stream. Previous year's questions. So this is the question number 1. So match list 1 functions and in list 2 Fourier transforms and select the correct answer using the codes given below. The list 1 and list 2. So these are the functions, time domain functions. So these are the so we can write this is x of t and this is x of j omega. Fourier transform. Then we have to match. So this is directly e power minus at u of t. We know that other formula. That is. So the first one formula e power minus at into u of t. So it's Fourier transform equal to, so 1 by a plus j omega. So this is a Fourier transform. So for a, where is answer? So this is a is alpha 1 by j. Omega, here this omega, it is an angular frequency, f is a linear frequency. That's omega equal to 2 pi f. 2 pi f. So in list 2, there is a second one. Then e power minus alpha t, it is also, we have the formula that equal to e power minus a mod t. So Fourier transform. It's Fourier transform equal to 2a by a square plus omega square. So e power minus alpha mod t, that equal to here this 2a. Omega is written by the 2 pi f. This is fourth one. So t into e power minus alpha into u of t, this is a differentiation property. Differentiation in frequency domain, we know that is already t into e power minus at into, in our subject, we have taken a in place of the alpha. So Fourier transform, so that equal to, we know that, so 1 by 1 by a plus j omega whole square. So 1 by here a is alpha, so there is 1. So this is like e power j into omega naught into t. This is frequency shifting. We know that for one Fourier transform equal to del of, sorry, so 2 pi 2 pi into del of omega. So that equal to Fourier transform. So that equal to, so frequency shifting. So that equal to 2 pi into del of omega minus omega naught. See, for the linear frequency, so we shouldn't take this 2 pi multiplication. Why we shouldn't take this 2 pi? I will tell you later in this video. Actually, we can write the Fourier transform for the angular frequency and linear frequency also. I will tell you. So for the linear frequency, so we shouldn't get this 2 pi multiplication. So simple del of f minus f naught. F minus f naught. So this is constant. So 2 pi alpha by t naught. So this is the frequency constant. 1 by t naught is the frequency. So that's why here, right? So alpha is a coefficient. Alpha by t naught actually, you can write like this: e power j2 pi. So this is f naught. So here f naught equal to f by t naught into t. So this is the constant. So in frequency domain, we should write del of f minus the constant. The constant is this one. So this is 3. So 2413 option B. So in this question, there are 4 questions covered in the one question. Next question. So this is next question. So it is asked in the ECE stream in engineering service examination. So a voltage signal V of t has the following Fourier transform. The energy that would be dissipated in a 1 ohm resistor fed from the V of t. So V of t signal is given to the resistor. So simple thing. For example, so this is the resistor. This is 1 ohm resistor. This voltage is given, and current passing through this resistor is I of t. Then energy. So energy is nothing but power. So energy equal to integral of the power. The first the power equal to, so P of instantaneous power, that equal to V of t into I of t. So in this so only V of t is given. So for this case, I'm going to convert the equation in only in terms of the V of t. Then I of t equal to V by R. Then so V square of t by R. The R equal to R. So the finally power equal to P of t equal to V square of t. So the energy equal to, so energy equal to integral of power into dt, total power. So that equal to integral of, so P of t, so V square of t into dt. So this is, we should find it, is it? So minus infinite to plus infinite. So this is energy. But here in the question, V of t is not given, but Fourier transform is given. But you don't try to find the inverse Fourier transform. Actually, we have the relation. This is the energy relation. That is Parseval's relation. So simply here I'm writing that relation. So integral of minus infinite to the plus infinite. So energy relation, that equal to, see, So x square of t, sorry, this is mod x of t square into dt, that equal to, so 1 by 2 pi integral of minus infinite to plus infinite x of j omega mod square into d omega. So there is no need to find the inverse Fourier transform. See, so this is, so same thing. So here, so integral of, so minus infinity plus infinity. So this is called Parseval's relation. Parseval's relation. So in this Parseval relation, now going to find the this energy. This is so in v of t, it is in the place of the x of t. So v square. So v of t mod square into dt, that equal to 1 by 2 pi. Its corresponding Fourier transform, this is v of j omega. So it has the value from -1 to the 1 only, that equal to mod of e power minus j omega d, the square into d omega. The mod of exponential goes to 1, then 1 by 2 pi. So it's one integration, that is omega, limits are 1 and -1. So then we are getting 1 by 2 pi to 1 of -1. So that equal to 1 by 2 pi into 2. So 2 gets cancelled. So that equal to 1 by pi joules. So option C. Next problem. So this is a, so read the question. The Fourier transform of e power minus pi t square is e power pi f square. Then the Fourier transform of e power minus alpha t square is what? So this is reference is given. So what is the reference is given? The reference that equal to, see here I'm writing. So Fourier transform that equal to e power minus pi f square. It's the Fourier transform of integral of, so minus infinite to the plus infinite, that equal to e power minus pi t square into e power minus j omega t into dt. This is formula for the Fourier transform. Now what we should find, that is integral of minus infinite to plus infinite e power minus alpha t square into e power minus j omega t is what? This is the question. So this value is what? This value we should find. Now my intention is I'm going to change this expression to this expression. So there is alpha, but there is no alpha. Then what I'm doing here? Integral minus infinite to the plus infinite, minus infinite to plus infinite. So that equal to, here I'm writing, so e power minus alpha and pi by alpha under root t square into e power minus j omega t into directly have written. So e power minus alpha. So there is a t. So I'm going to change this variable. So pi by alpha under root t, I'm assuming tau. So dt equal to d tau into under root of alpha by pi. And t also t equal to, so t equal to under root of alpha by pi into tau. So now integral minus infinite to the plus infinite. So e power minus alpha tau square into e power minus j omega. So what is the t? Alpha by pi under root of tau into dt equal to d tau into alpha by pi under root of alpha by pi. See, here I'm changing integral of minus infinite to the plus infinite e power minus alpha tau square into e power j 2 pi f root alpha by pi into tau into d tau into root alpha by pi. But so this is actually this is again, so this is applicable for the f equal to here f, but there is no f, so f is multiplied by the root alpha by pi. Again here I want to change, so f root alpha by pi equal to capital F, then f equal to root pi by alpha f. So for this case, integral minus infinite to plus infinite. So this is alpha by pi root of e power minus alpha tau square e power minus 2 pi f into tau d tau. See, so this value we should know. So this is same. So this is equal to, so send to the left side. Now this is, I'm sending to pi by under root of pi by alpha into e power minus pi. What is the pi value? Pi values we should replace pi by f under root of f whole square. Then in final step, so under root of pi by alpha into e power minus this is square under the root and square gets cancelled, then we will get pi square f by alpha. So this is the case. Sorry, f square, f square. So this is the answer. Next question. So, so this is a question. So Fourier transform of x of f of periodic delta functions. So we know that for a linear, angular frequency, for example, on x of t that equal to sigma k equal to minus infinite to plus infinite. So del of t minus k into t, its angular, its Fourier transform in angular frequency that equal to 2 pi into ak into del of omega minus k into omega naught. K from the minus infinite to the plus infinite. But in the linear frequency, we would not get the 2 pi. So this ak. So for this periodic signal, that ak value, the ak value equal to 1 by time period. So in linear frequency, this is for the angular, means in terms of omega. For linear, so the formula equal to x of t del of t minus k into t, k equal to minus infinite to the plus infinite, its Fourier transform equal to k equal to minus infinite to the plus infinite, ak into del of f minus k into f naught. Here this omega naught equal to 2 pi by t. Here this f naught equal to 1 by t. So here also ak equal to 1 by t. Then so sigma k equal to minus infinite to plus infinite. So ak is a constant 1 by t. Del of f minus k. Here f naught is not given. That f naught equal to 1 by t. So this is it. So 1 by t of, so frequency, but this is the time. It should have k by 1 by t. So option. What is the inverse Fourier transform of u of omega? Say u of t Fourier transform equal to 1 by j omega plus pi into delta of omega. Fourier transform. Similarly, duality property, here applying duality property, that equal to 1 by jt plus pi into del of t. So from the duality property, that equal to 2 pi into this one. So that equal to u of omega. So what he is asking? Inverse Fourier transform u of omega. Then that equal to, so inverse Fourier transform of u of omega, that equal to 1 by 2 pi 1 by jt plus pi into del of t. So that equal to 1 by 2 pi jt plus del of t by 2. So this is the answer. So option A. So this is a question. The relation between input and output of continuous time system is given by. So what is the force response? What is force response? In the response, there are two parts. One is steady state response, and another one is transient response. The steady state response also called as a forced response. So when x of t equal to k. So this is, I think, x of t is given t greater than 0. So the given, so we have to find the y of t. Y of t, uh, it may have forced response and transient response. I'll show you. So first of all, so this is a first order differential equation. Actually, we can do this one with the help of network theory and also in mathematical, in Laplace method also. But here I would like to solve this one with the help of the Fourier transform. So for that, so d by dt of y of t plus 3 into y of t, that equal to x of t. Now, first apply the Fourier transform. Then so this is Fourier transform equal to j omega. So j omega y of j omega plus 3 into y of j omega into x of t is a unit step. So unit step Fourier transform equal to k into u of t, already t in, so that equal to k by j omega. So y of j omega is a common, then what we're getting? So 3 plus j omega. So that equal to k by j omega. So y of j omega equal to k by, so j omega into 3 plus j omega. So again, if you want to find the y of t, again we should apply the inverse Fourier transform. Here j omega 3 plus j omega, we need to split into two parts in partial fractions. For that, from the mathematical, this is related to mathematics. So here directly I'm writing, say 1 by j omega minus 1 by 3 plus omega, then simplify this one. Again here we'll get 3. So that's why here I'm writing 3. Simplify this one, then you will get this equation. I will tell you this concept in Laplace. You don't worry. We will discuss this partial fraction, everything in Laplace. So now apply inverse Fourier transform. So inverse Fourier transform. So inverse Fourier transform, that equal to y of t, that equal to k by 3 is a constant. So k by 3, this is for unit step. So u of t, this is also e power minus a into t. So minus a equal to 3 into t into u of t. So here we got the response. So that equal to k by 3 into u of t minus k by 3 e power minus 3t into u of t. So this is called steady state response. Steady state state response. This is transient response. Transient response. So this forced response also called as steady state. Then the answer is k by 3 into e of t. So I already here for the positive. So this is option B. Think yeah, it is finished. No. Okay. So these are the previous year questions. So still now we have discussed everything. Then so in next class revise the whole chapter. Okay. Thank you.